So if we take a look at this diagram, right, we have the sunlight coming in. This is the Sankey diagram, so all these columns are proportional to what they actually, represent. So, the sunlight's coming in, and some of it, gets reflected off the sun. Some of it actually gets reflected off the surface. Some of the light is coming in and hits and is received. Some of it's absorbed by the atmosphere. And then if you look at what's happening with the Earth, right, the Earth is radiating out a lot of infrared. Now, those greenhouse gases absorb infrared. And so some of them, get absorbed and then they're sent back to Earth. Some of them make it into space, right? Some of the greenhouse gases themselves, after they absorb it, send it to space. And so, without the greenhouse gases, right, we wouldn't have all this coming back in, because if the Earth is radiating out, infrared, and then the greenhouse gases absorb it and send it back to Earth, if we didn't have that, our Earth would be far too cold, if we didn't have the greenhouse gases. And so if we have too many greenhouse gases, then the temperature of the Earth gets hotter and hotter and hotter. Here's another great diagram for that. And if you want to take a moment and pause and pause the clip and take a look at it, this is another good depiction of what's happening, another good Sankey diagram. Here's a third diagram that's really helpful, giving a visual of the greenhouse gas effect. So go ahead and pause the clip here and make some observations, and then when you're ready, you can hit play to continue to the next slide. Okay. So when we summarize the greenhouse gas effect, the warming of the Earth is caused by infrared. So, the Earth's surface emits it out. Some of that's absorbed by the greenhouse gases, and then some of it's sent back to the Earth. And so it's a cycle that way. The gases primarily responsible for the absorption are water vapor, carbon dioxide, methane, and nitrous oxide. When we talk about the mechanism of photon absorption, it's important to be able to describe that. The greenhouse gases absorb infrared. They're excited at higher energy levels. And, the gas molecules want to be at the ground state, so they're going to shoot out the photons once they receive them. And they're going to shoot them in all directions. And then some of them will come back to Earth, where the Earth will receive those again, warm up the Earth, and the Earth will send infrared back out. And the process, begins again. So when we talk about, the greenhouse gas effect, the big, hot topic, about this is the, contribution mankind is making to it. There's certainly other sources for the greenhouse gases, but when we consider the gases being produced by mankind, yeah, it's kind of interesting to see that dynamic and see, how much we actually are, which is quite a bit. And so this is a flow diagram of how much energy is being used. The one that I like a lot is looking at this one here, where we have a breakdown of the different energy sources, and essentially how much we use. And so by far petroleum is used a ton, and vehicles use them, freight aircraft use it. And what's interesting is, this is the total amount, and then you can see here is the loss, right? So all of these, for instance, with petroleum and what's coming over here, a little bit of natural gas and a little bit of biomass, right, with the ethanol, but a lot of this is lost, right? So this is what's coming in. These are the energy sources, but this is how much is lost, right? This is the useful energy, right? So, not getting nearly as much out of, as compared to even the energy loss. You can look at how different things are being powered, where natural gas is being used. A lot of it's producing electricity, but then you also have industry using it, commercial and residential, places using it. Coal, pretty much almost all of it is going to energy production. You have a sliver here with nuclear, which is all energy production. A little bit of solar, a little bit of wind, a little bit of geothermal, biomass, and hydro, contributing to the electricity generation. Hydroelectric, right? It's a dam Biomass, we're dealing with, ethanol. You can use corn, make ethanol, and then burn it and use it as a fossil fuel. Well, use it as a fuel for vehicles. And geothermal, you're pulling hot water from underneath the Earth's crust and, ducting that around. But you can see how small those are. We're still very dependent upon the fossil fuels here for our energy. So, oil, 32% of energy production, we've got, carbon dioxide coming out of that. Natural gas, coal, we can see the percentages here, 6% with nuclear, hydroelectric 2%. So oil by far, was actually in terms of energy sources, you have 32% coal is comparable, but nuclear is smaller, hydroelectric, biofuels we've got there and others. Even smaller than that. This is kind of an interesting diagram as well, where we're looking at million metric tons of carbon dioxide. So, coming from the different sources, petroleum is a lot of carbon dioxide created, natural gas, right, renewables. And this is where they're being used. And so you can see in industry, it has a huge chunk, right, as well as transportation, a little bit smaller chunk with commercial and residential. And it's interesting, they include the territories and bunkers in here too. And there's other types of gas, right? And so if you look at that, this here, this is other types of gas, methane, nitrous oxide coming out. And, these are contributing to the greenhouse gas effect. Okay, so with the enhanced greenhouse gas effect, we have the fact that with enhanced greenhouse gases leads to increased warming. That's because, ocean water, as the temperature increases, there's more evaporation. You have more water molecules in the air, and so you have the increased greenhouse gas effect. And then if you have less ice, glaciers, snow, that means that there's less reflected back into the atmosphere. Therefore, more light is absorbed by the Earth, and we have more infrared that can be sent out from the Earth and then, absorbed by the greenhouse gases and sent back down. Warming. And these are caused by the, increase in different types of, greenhouse gases in the atmosphere. And so, it turns out one of them is the water molecule. So the more water vapor that is in the air, the greater the greenhouse gas effect. And so we have quite a few natural resources or natural sources of this, evaporation for water from lakes, oceans, and rivers. Human sources, irrigation. And the next one here is the oxygen molecule, and so sources being, forest fires, volcanic eruptions, evaporation of water from oceans, and, human sources, burning fossil fuels and power plants and burning forests contribute to that. We have methane, CH4, and some sources of that, wetlands, oceans, lakes, rivers, even termites. Human sources, flooded rice fields, farm animals, processing of coal, natural gas and oil, burning biomass. Okay. Nitrous oxide as well, so some natural sources, forests, oceans, soil and grasslands, and some human sources, burning fossil fuels, manufacture of cement, fertilizers, deforestation, reduction of nitrogen fixation in plants. So conservation of energy is still a really important idea, and we've looked at throughout this unit the conservation of energy within the different processes, and then there's a lot of loss, right? And so in that loss, it's not just going into nowhere, right? But some of it's taken in friction, shaking particles elsewhere, internal energy increasing in another part of the system. And so we know that energy is neither created nor destroyed. Now, when we get into next year, we'll look at energy plus mass, because really you can't separate the two. We can only transfer energy from one to another. So for instance, going from kinetic to potential energy, and then into internal energy through friction, right? As an example. roller coasters can't make it up to the initial height because of friction, right? So some of that energy is transferred into the track, into the wheels, into the air resistance of the air. The air particles are moving faster. So some of it's lost in the internal energy there. And so obviously the hills must decrease in height along the way, and you can see that in this picture. Electrical to light energy is one thing that we can have, and we're going to look at that quite a bit next year. Electricity flows through the wire and reaches the filament. Filament gets really hot, the atoms get excited, electrons move to higher energy levels and then come back to the ground state or an intermediate state shooting out light. As they go, like I said, as they go back down to the ground state or an intermediate state, they shoot out light, and the current will slow down. So energy is transferred to the current, or from the current to light energy, and so it's using up a certain amount of voltage, and we're going to look at that next year, and radiating that light out. Chemical to electrical is also going to be a major one that we're going to look at. In a chemical reaction, you have a battery, right? And so electrons will end up flowing and producing electricity. We'll look at how the battery works next year to produce that electricity, but it's through chemical reaction. Electrical to mechanical, so you can have electricity move moving parts. In our robotics club, we have motors and servos. So we're sending electricity through and moving arms and moving wheels, and so you can spin things. And an example, the big example here is an electric motor, right? So electricity sent through and the motor is spinning, and you have a fan like this, or have a mixer like this, spinning, and the motor is spinning that. Light energy to electrical, so we have solar cells, not panels, right? But solar cells do this, transfer light into electrical energy, and you've seen those, and that's kind of the promoted, about using these for electricity production. If you think about your car, a lot of different energy transfers in your car, chemical to mechanical, right? So eventually, you have the chemical reaction in the battery, then electricity going out, and this is directly connected to the mechanical parts, with your alternator in your car producing electricity, which sends to the rest of the system. Your car burns the gasoline, and as that happens, it turns the wheels of your car as well. And so that we have a lot of different energy transfers in a car. Another type is mechanical to electrical, and so this is where alternators are spun by the engine. They recharge your battery.